Yeah, I'm also in English. Good afternoon, everyone. I'm from Shenzhen ProSense Technology Corporation Limited. We are a gas sensor manufacturer. This is my first public English presentation, so please forgive me for my poor English ability. The first part is about our company. Now we are the TC member of UL 2075, 2034, and 2201. We are the sole gas sensor manufacturer in these three TC. I think this is the highest recognition of our technical ability. Our company, we only have 4 gas sensors, but all of these 4 sensors, we are the #1 in the world. The formaldehyde sensor is our first one. Now it has more than 90% market share in China, and we have the UL recognized the carbon monoxide sensor and the hydrogen sensor, which is for lithium battery safety. And also the second one is the hydrogen sulfide sensor designed especially for the solid electrolyte lithium battery. Why our sensor is so liked by our customer, especially the formaldehyde sensor, because our R&D team has been keen on this fuel cell technology for more than 20 years. And once we make a gas sensor, we will do some in-depth research about the vertical application, because only when you can know what is the really demand of this field, you can make a good sensor. And we make our own catalyst, which can ensure our sensor's performance. Just like the CO sensor, it can be used for the residential CO alarm and for the portable generator and also the BESS. But the performance requirement is quite different for these 3 applications. So we must know which field the sensor is targeted for and what is the biggest challenge for this field. Now for the safety, the battery safety, what is the global challenge now? There are a lot of reports yesterday about the battery safety. I think the biggest hazard for the thermal runaway is the liquid electrolyte, which is very flammable. So to enhance the BESS safety, we need to have a good sensor for the right prevention action and also to enhance the intrinsic safety. And if we can use the solid electrolyte battery, we can solve the problem completely, because when there is no liquid, flammable liquid, there will not be fire. And nowadays, the gas detector is widely used, especially in China, for the lithium battery safety. From this picture, we can see that hydrogen and carbon monoxide are the two good gas that can for the prevention of the thermal runaway. And in China, we usually detect carbon monoxide, hydrogen, and VOC. And outside China, there are carbon monoxide, hydrogen, and off gas. When we are using this gas detector, we hope that the detector can give us a timely and right alarm for us to take timely and effective measures to prevent serious loss. But is that the reality now? The answer is no, because there are a lot of false alarm and missed alarm on site. Why? I think the sensor and the alarm threshold is not properly selected. This is the work from the NFPA 855. it suggested that we should use an off-gas sensor that is for the detection of vapor, electrolyte vapor, because it can be detected at the very early stage, and it doesn't suggest for the application of a flame ball gas sensor, because they think there are no good gas sensor that can detect flame ball gas at a very low concentration. But is that the reality about the off-gas sensor and also the flame ball gas sensor? And this is the requirement of the GB, the Chinese standard. They suggest that the threshold on site should be set at 190 ppm, but is this the right threshold value for this application? You can find the answer later. For the gas sensor, there are 6 principles. Gas sensor is a very good way because it is cheap. It can detect online. In fact, it is monitoring, not detect. Detect means it can from time to time, but online, but monitor means it can work all the time. I will not give introduction about the principle because the time is limited, only the disadvantages of every principle. This is the electrochemical sensor, which has the history of more than 15 years. The biggest disadvantage is that there is the leakage possibility of the liquid electrolyte, and it is usually used for industry safety. The lifetime is very short, only about 2 years. And for the application industry, it is required for the recalibration in laboratory once per year. So it is not suitable for this application because when it is used for the EV, for the BESS, you cannot take it back and recalibrate. This is the sensitivity drift of this principle. And this one, his age is older. This technology is older than the electrochemical sensor. It has about 70 to 80 years history. And it is ideal choice for the high precision and long service life requirement. And this is the sensitivity drift. And the hydrogen sensor, and for the monoxide catalytic sensor, it has the big problem of silicon poison. And now there is a widely used technology set off-gas. In fact, the off-gas sensor is really a MOX sensor, which has the problem of big offset drift, and it is easily poisoned by the silicon. So it has a very big problem when it is applied on site. This is the test data. And it also has poor selectivity. It will give false alarm when it is used. And this is the offset drift and the silicon poisoning experiment. And this is a thermal conductivity sensor. This sensor can detect almost every gas because different gas has different thermal conductivity coefficient. There's a manufacturer in China, they claimed that they can detect 100 ppm with this technology, but the humidity, if we only change the humidity of the environment, the sensor will give almost 2,000 ppm hydrogen output. So how can it detect 100 ppm? And for the APIR, it will be seriously affected by water. So for the application for the lithium battery safety, I think the fuel cell technology is the most suitable one. ProSense has the UL recognized carbon monoxide and hydrogen sensor. And these are the high temperature performance. And this is for hydrogen. And for the sensors used, the fuel cell sensor is the best one. But if we can use the solid electrolyte gas battery, we can solve all the problem. but there is also the safety issue for this battery. Because when the electrolyte meets with the moisture, hydrogen sulfide will be generated. Hydrogen sulfide is very poisonous to human. The alarm threshold is 10 ppm. For the detection of 10 ppm, only electrochemical and the fuel cell technology can be used. These are the test results of these two principles. From the first picture, we can see the electrochemical sensors. When it works at high centigrade, at high temperature, the sensitivity will drift greatly. And these are the fuel cell sensor storage at 85 centigrade and working at 105 and -40 and the room temperature. So that's all for this presentation. If you want to know more about our product, you can contact us. Thank you.
OK， 感谢赵总的分享。然后我们现在大家有什么问题或者建议，都可以提出来，有时候任何人想提问的。Any comments and questions are welcome.
Yes, I have one comment. Sorry. You mentioned this is the first time you make a presentation in English. This was a great presentation. Thank you.
Thank you very much.
Thanks.